My warm greetings to one and all present here, respected dignitaries, our beloved faculty, and my fellow friends. A very special morning to one and all. I'm Akshata from Artificial Intelligence and Machine Learning AIML Department. I'm so privileged to extend my warm welcome to everyone present here for Day 3 for this workshop, Professional Development Program on Applied Artificial Intelligence and Expert Systems, organized by Department of AIML. Now let me introduce the speaker for today. Dr. M. Rajshekhar sir has 22 years of teaching experience and taught several subjects, 16 years of research experience, and has written textbook on Introduction to C Programming. Sir has recorded 710 YouTube video lectures on subjects like ethical hacking, applied data science, artificial intelligence, Java programming, Python, formal languages and automata theory, data structures to C, NEP 2020 and NIRF with named Rajshekhar classes. He has published 42 papers in reputed journals, guided 30 MTech projects. He has pursued his BTech and CSC from IIT with gold medal, completed his MTech and CSC from IIT Dhanbad, MSc Applied Mathematics from University of Hyderabad, Masters in Philosophy from University of Hyderabad. Sir has also done MBA from JNUH and PhD from JNUH. His motto is to build free learning ecosystem in data science, artificial intelligence and cyber security. Over to you, sir.
Yes, I think I am at. Thank you for your nice and kind introduction. In this lecture, we will try to understand something related to probability. Even I can say something related to Bayes theorem, Bayes applications. Actually, I have seen your syllabus. I thought that better to explain a little bit case study, little bit statistics, little bit probability. If I am able to explain that probability and statistics with the help of simple toy data set, you may get deeper intuition. We will see how it works. Let me start my session. Let me explain this particular concept with the help of one simple, I must say, one of the important algorithm in artificial intelligence. For that matter, I can say in machine learning. We will try to understand things with a simple data set, how it works, we will see. First, but let me set the stage for let me introduce few things. First, you might have heard about this particular Bayes theorem. Maybe forget about engineering, you might have learned in your intermediate itself. Then what is this Bayes, how it is related to artificial intelligence, how it is related to machine learning. We will try to understand. Basically, let me say a few words about this particular algorithm. I can say Bayes is one of the classification algorithm. Actually, there is something like classification means what? There is something like spam filters. I request all the students to be silent, please. Yes, you must be silent. If you have any query, if you want to ask anything, please you can ask without any hesitation. Yes. Anyway, basically, why we are interested in understanding this particular algorithm, as we are saying, this is one of the classification algorithm based on fundamentals of probability. Simple example, I can say there is something like spam mail or not spam or not. Whether to check whether given mail is related to spam or not spam. Certainly, this particular algorithm will classify. It will tell that your mail is spam mail or not. Isn't it? This particularly this algorithm based on a concept known as probability. I can say it's a probability based technique. I don't know, so maybe some of you might have heard about an algorithm. There is something like k-nearest algorithm, k-nearest neighborhood algorithm. Being students of this particular branch, certainly you will learn this algorithm if you maybe in future classes. Somewhere certainly you will come across this particular algorithm. This is also one of the famous algorithm. But what is the KNN is very simple. That KNN is also a classification technique, but KNN is based on something like neighborhoods. There is some concept like neighborhood, depends on neighborhoods, it classifies things. But whereas our neighbors classify things based on probability. Before understanding naive-Bayes, we must understand fundamentals of probability. First such fundamental is conditional probability. Yes, it's not new thing. Let me refresh, let me recall what you learned by, because without this base you cannot do anything related to what you talk. You have topics related to this one only. If you understand this concept, certainly one can understand anything. I can say these are the fundamentals. Yes. Yes. In order to understand, let me refresh our knowledge on Bayes theorem. Let me go to this. Just check this one. This is a page from Wikipedia. Give me 1 minute time. Am I audible? Yes. If you are not audible, just call me. Okay. Anyway, just see this one. Maybe it's visible. If you see this one, wikipedia.org wiki conditional probability. Just go to Wikipedia and type condition. Just go to Google, say Wikipedia conditional probability. Just you will get this particular thing. Yes, and anyway, this one is as the preliminary classes thing, but let me spend few seconds. What it says here, I have something like D1. D1 means die 1. D2 means die 2. If I throw a die, what are the possible outcomes? I will get 1, 2, 3, 4, 5. There 6 possible outcomes, isn't it? Just see here, I am taking one die. Another die I am taking. Just this is a page from Wikipedia. How he is explaining Bayes theorem. Just let me try to highlight it. Yes, what is he saying? What is this table indicates? This table indicates D1. This plus means what? D1 plus D2. D1 plus D2 means for D1 how many possibilities? There are 6 possibilities. For D2 also there are 6 possibilities. D1 plus D2 means your minimum value will be 2, your maximum value will be 12, isn't it? Now, how we are trying to set a stage to understand Bayes theorem and related classification. Actually, what it says, just see. P means what? Probability D1 plus D2 less than or equal to 5. What does it mean? How many possibilities are there? If I throw 2 dice, I will get how many possibilities? I will get 1, 1, 2. I will get 6, 6. That is my sample space, isn't it? Total possibilities, there are 36 possibilities I will get. What it says, probability of getting summation
less than or equal to 5. Less than or equal to 5 means what? Just see this red portion. Is it not less than or equal to 5? It's a less than or equal to 5 portion. How many such cases are there? If you count, I think 1, 2, 3, 4, 4 plus 3, 7, 7 plus 2, 9 plus 1, 10. There are 10 cases whose summation is less than or equal to 5. How many total number of cases? There are total 36 cases. Therefore, can I say probability of D1 plus D2 less than or equal to 5 is 10 by 36. It's not great thing, it's not new thing. Yes. Now, my intention is to explain conditional probability. We just we discussed what is probability. Now we will try to understand. We will try to apply for conditional probability. What is conditional probability? Generally, how we used to write P of A by B, isn't it? What is condition? Probability of A. What is the condition? Condition is given P. That's the meaning of P of A by B, isn't it? Probability of A when P has happened. Isn't it? It's something like that. In similar manner here, what is D1 equal to 2? That is just like an event A. D1 plus D2 equal to 5 is just like event B. Probability of getting die 1, number 2 on die 1, given that D1 plus D2 less than or equal to 5. Is it not conditional probability? Yes. What is this red portion indicates? Red portion indicates D1 equal to 2 and D1 plus D2 less than or equal to 5. How many such cases are there? D1 plus D2 less than or equal to 5. How many such cases? How many such cases are there? N cases, just see. In which what is the condition here? Condition is D1 plus D2 less than or equal to 5 condition. I need probability of D1 equal to 2 when D1 plus D2 less than or equal to 5. Probability of A given B. Here given B in the sense D1 plus D2 less than or equal to 5. Is it not how many such is it not 3? Is it not 3 by 10? There are 3 favorable cases, total 10 cases. That's what it says. This is how it works. Just we are trying to set a stage to introduce this particular algorithm. This is called conditional probability. It's not new thing. Just say this one. What we are saying, same thing. D1 equal to, just I am denoting by A. D1 plus D2 less than or equal to 5. I am denoting that particular event by B. I can say this is P of A by B. P of A by B means what? Probability of A given B. That is definition. Conditional probability definition is P of A intersection B by P of B. Just see, that's what this Wikipedia page also is. P of A by B is equal to P of A intersection B by P of B. What is my P of A intersection B? It is 3 by 36. What is my P of B? 10 by 36. We know what is A, what is B. I already explained what is A, I already explained what is B. Ultimately, what will you get? You will get 3 by 10. Isn't it? Yes. Now, that's what definition says. Same thing I am reiterating, just we are reiterating. Yes? Yes. Yes. There is something like independent events. What is independent events? This is basic definition. Two events A comma B are said to be independent. The probability of A given B is equal to probability of A means what? Doesn't bother about B. P of A by B equal to P of A means it doesn't bother about B means are they independent or dependent? Independent. That A is not caring about B. Isn't it? That's some P of B by A equal to P of B. That anyway that one can easily understand. It's not a big thing. It's not a great thing. That is, you might have seen, you might have understood about mutually exclusive events. What are the mutually? These are the basic things. Independent events, mutually exclusive events. Mutually exclusive means what? If I toss a coin, getting head is an event, getting tail is an event. They are mutually exclusive, isn't it? Both cannot occur at that. That is mutually exclusive, isn't it? Means their P of A intersection B equal to 0 means what? They cannot occur together, isn't it? Then I can say they are mutually exclusive events, isn't it? Yes. Anyway, this is a little bit introduction. Yes. That's what this is one of the famous theorem. This is the theorem. Being an artificial intelligence students, being a machine learning students, certainly you will come across this particular theorem. You might have learned that this theorem in your, as I told you, in your intermediate, even in your basic probability also, but which has got super applications in machine learning, which has got super applications in artificial intelligence. I can say Bayes' theorem is one of the fundamental theorems in probability. It is very simple, elegant and beautiful and useful theorem. It is very older technique, even it is introduced in the early 1700s by great mathematician Thomas Bayes. This is very old theorem, very useful also. Now let me state the theorem, then I will prove. This proof is also very simple, very easy. Actually, this is applicable for all filters like spam filters, for so many classification tasks. How will it be? We will try to understand real mathematics, real probability behind all those spam filters. Yes, this is simple statement. P of A by B is equal to P of B by A into P of A by P of B. You must make sure your probability of B must not be 0. This P of A by B is known as posterior probability. P of B by A is known as likelihood probability. P of A is known as prior probability. This P of B is known as evidence. These are basic terms. In probability, generally, we used to write, this is one simple notation people used to write like this. P of A intersection B can also be written as P of A comma B. They are of same meaning. P of A intersection B can be written. This is a notation. Sometimes the P of A intersection B can be written as P of A comma B. Anyway, how it works, we will try to understand. This is very simple proof. Just see, this is the statement as we were discussing. How this is applicable in Bayes filters, we will try to understand. Yes, what is the statement? Statement of Bayes theorem is this one. This is the statement. Yes, what is this? P of A by B is equal to P of A intersection B by P of B. How do you know? This is a definition of conditional probability. As I told you, this is simple notation. People used to write P of A intersection B can be written as P of A comma B. They are of same meaning. A intersection B or A comma B are they are of same meaning. Now, P of A by B. What is your P of A by B? P of A by B means this is definition. P of A by B equal to P of A intersection B by P of B. This P of A intersection B, according to notation, I can write A intersection B is same as A comma B. Just it is simple notation. That's what I am saying. This wherever P of A intersection B appears, that you can write it as P of A comma B. Isn't it? A intersection B equal to B intersection A. From set series, I can say P of A by B equal to P of A intersection B by P of B means that can be written as P of B intersection A. Even that P of B intersection A can be treated as P of B comma A. Isn't it? Now we are just I'm writing definition for P of B by A. Just it's a matter of what am I doing here? Just I'm cross. If you cross multiply, what will you get? What will you get if you cross multiply this one? P of B intersection A equal to P of A into just I'm cross multiply things, nothing more than that. Now what I am doing, what I need, substituting 2 in 1. What is my second equation? I am keeping second in 1. What is my 1? What is my first equation? P of A by B equal to, in the place of P of B intersection A, I can write just I am substituting 2 in 1, nothing more than that. Just it's a simple mathematics. Maybe it may not advisable to spend so much of time as it is very fundamental school mathematics. Yes. Anyway, you might have learned about applications of Bayes theorem. This is famous problem in your regular exams in any question paper, maybe in your 10+2 question papers, in your BTech question papers. This is standard question on Bayes theorem. There are missions M1, M2, M3. They are producing some sort of output, some defective output, those things. But as these are very simple things, just I want to show this slide, nothing more than that. There is no point in explaining same mathematics which you learned long back, even in your BTech curriculum also. Just I would like to show the application of more than that. Yes, this is one simple problem. Yes, now our intention is to build a probabilistic model, whether it is artificial agent, whether it is artificial medicine, whether it is some machine learning algorithm. What we need probabilistic models. Actually, in your syllabus, to understand these probabilistic models, what we did till now, we built some sort of background. Yes, again, this is a Wikipedia page. I collected from Wikipedia. Just see Wikipedia name-based classifier. Just this is the page. What it says. This is X. X means what? X1, X2, Xn. This is, I can say, a vector representing n features. What is this features? We will try to understand. As I told you, we will try to understand things with the help of simple toy data set. There is one simple toy data set. We will see how it works. Before understanding with the help of toy data set, let me say a few words. Just let me read this one. Naive-Bayes is, just give me 1 or 2 seconds time so that I will explain. Let's understand Naive-Bayes algorithm. Right now I am on the Wikipedia page. This is Wikipedia page on Naive-Bayes classifiers. Naive-Bayes, as the name suggests, Naive-Bayes, this is the name that the classifier, why people are calling it as Naive-Bayes. Bayes is the name, why it is using the concept from Bayes algorithm. That's why people adopted that Bayes term, comes from Bayes theorem. Naive, English meaning is, what is the name? What is the meaning of naive? Why people? There are two terms in the Naive-Bayes algorithm. One term is naive and another term is Bayes. As we are saying, this term Bayes adopted from Bayes theorem, then what about naive? We will try to understand. What is this naive? Just see, naive means what? It's just if you go through the dictionary definition, naive means unsophisticated. Naive means, I can say, it's a simplistic algorithm. Yes. Why it is unsophisticated? What is its simplistic algorithm? Why people are calling it as simplistic? There is an assumption in Naive-Bayes algorithm that we will try to understand. Time being, let me say, it is basically simplistic or unsophisticated algorithm which uses Bayes theorem. Again, Bayes theorem is so fundamental to the whole area of Bayesian statistics. There is something like Bayesian statistics, but time may not permit me to look into those Bayesian statistics as they are. Yes, sir. Yes, sir. Sorry. Yes. How we will try to understand this one. First, we will understand mathematical part. Imagine I have a vector. Let me say this is my vector. Just wait. Only 1 second. Yes. This is my vector. x1, x2, xn. What is a vector? If, for example, if there is a query, if I want to represent some query, if I want to represent some features, we will try to understand. Actually, I am trying to set a stage to understand particular data set. Let me say I have a vector x equal to x1, x2, xn. What is the dimension of this particular vector? N-dimensional vector. How many features are there? There are n features. This is the data point. X is my data point, x1, x2, xn. For which I have how many features? I have n features. x1 is one feature, x2 is another feature. Till I have n features. This is the data point for which I have n feature, and let's assume I have k possible classes. That is important. K possible classes. This point one must understand. Number of features are n. Number of classes are k. I must, for example, spam detection. How many classes? Let me assume in spam, there is an algorithm for saying whether a particular mail is spam or not spam. How many classes? There are 2 classes, isn't it? Here, k equal to, if it is spam detection, this is k2. Your KNN your naive Bayes can perform not only binary classification, it can perform multi-class classification depending on the context. For simplicity, people used to discuss with 2 classes. Anyway, here these 2 points one must understand. First point is, I have a vector with how many features? With n features. How many classes? K classes. Means for a given vector in the sense, for a given email, for example, I must say to which class will it belongs. I have received an email, that is my capital X, with some n features. Now, how many classes are there? Let me assume there are 2 classes. Your algorithm must say, yes, this is the mail, this belongs to this spam. This is the mail, this belongs to not spam. That is the intention. Anyway, how to build, we will try to understand. Try to have clarity on notation. Again, I am saying, I have a vector with n features. I have k possible classes. My data points belongs to any one of these classes. My vector x may belongs to class 1. My vector may belongs to class 2. My vector may belongs to class 8. I don't know which class will it belongs. Who will tell which class will it belongs? If I apply this particular algorithm, I can see. How we can apply? We will see. Just see in Wikipedia page also what is the saying? Just see. K possible outcomes. Classes CK. Classes CK. Classes CK means if I keep k equal to 1, C1 class. If I keep k equal to C2 class. So on, k classes are there. For example, in the case of spam, not spam, C1 is, let me say, spam, C2 is not spam. Like that. Isn't it? How it works, we will try to understand C1, C2, C3, so on, CK. So this is the, if k is greater than 2, I can say it is multi-class classification problem. If k equal to, if number of classes are 2, I can say it is binary classification. It can be extended to multi-class classification also. Now, what do we want to find? A data point x is a vector. We want to find what is the probability that given x, what is the probability? Just say this, P of Ck by x. Is it not conditional probability? P of Ck by x means what? Probability of Ck given x. Given x means what? Given x means given query point x. I have a query point x. I must find, if I keep, let me say in this formula, if I keep k equal to 1, what happens? P of, what will I get? P of C1 by x value I will get. We will do how to do it, it's simple. If I keep k equal to, I will get P of C2 by x. If I keep k equal to 3, I will get P of C3 by x. What is this piece? P's are basically probabilities. What is the meaning of P of C1 by x? For given query point x, what is the probability? It belongs to class 1. For given query point x, what is the probability? This particular x belongs to class 2. For given query point x, what is the probability? It belongs to class 3. That I would like to find. For example, in this case, how many probabilities I will get? I will get 3 probabilities. Can I get 3 probabilities? Certainly I will get. Anyway, how will it be? We will try. Just try to understand mathematical part. Once if you understand mathematical or probability part, applying things is very simple and straightforward. Just let me prepare a stage where one can understand things without any difficulty. Yes, so P of Ck, this terminology I already discussed. What is P of Ck? There is something like, people used to call it as prior probability. P of x by Ck is known as likelihood probability. This P of x is known as evidence probability. Isn't it? That's what we were discussing about it. Now, after finding all these probabilities, I must say, let me write like this, otherwise, let me find P of C1 by x, P of C2 by x, so on. How many probabilities I can find P of Ck by x? I will find P P of in between P of C3 by X. Basically, probability is a number which is always lies in between 0 and 1. It cannot exceed 1, isn't it? Therefore, I will get all the numbers. Can I compare numbers? I can compare numbers. Two numbers can be comparable. Of course, if they are complex numbers, I may not be able to compare. Can I compare two complex numbers? I cannot compare two complex numbers. Of course, their magnitude can be compared. But as a numbers, I cannot compare. Anyway, probabilities are basically real numbers. You don't have any issue. You can compare real numbers with each other. I can find. Let me say among all these probabilities, let me say I have got P of C3 by X is maximum value. You know, we have values C1 by X, C2 P of C1 by X, P of C2 by X, C3 by X, so on Ck by X, in which in all of them, which value is highest value? Which value is highest value? P of C3 by X is highest value, isn't it? If P of C3 by X is highest value, one can consider this data point X belongs to class C. If there are K classes, which class that particular data point X belongs? For whichever probability you are getting higher probability, that corresponding class of that's the probability, isn't it? Anyway, how it works? We will try to understand with the simple mathematics probability technique. Just see this one. Yes. Let me say this this particular what is this? Just a minute. Let me go back. Yes. I will analyze this particular formula. Just to have an idea on it. P of Ck by X. Is it just like it is conditional probability? P of A by B equal to P of A into P of B by A by P of B. Yes, we will try to understand this particular formula. If you observe carefully, here we have just let me say if I keep K equal to 1, what will you get? Just let me spend only 2 minutes here. P of C1 by X is equal to, what will I get? P of C1 into P of X by C1 by P of X. This is P of C1 mixed. It is not depending on your K. Is it depending on K? Therefore, in that case, can I remove this constant and can I keep something like proportionality? That's what simple mathematics. See, you can remove that constant. You can write something like A equal to some B by K means by removing K, I can say A proportional to B sort of. That's basically a number which remains same throughout all values. Which it is independent of K. Whichever K value you will keep, that P of X remains same. Therefore, let me try to take advantage of it, and we will try to understand how it works. We will see. Just see this one. Yes. This is my term. Which term? Which term? This one. P of. What is this term? P of Ck. Ck means what? Class. What is this x1, x2, xn? My vector, x. Very vector. Yes, isn't it? This is P of Ck of, this is again, my dear friends, all this stuff from Wikipedia. I have not written all these things. Just for subjects like, okay, anyway, I don't want to deviate from regular discussion. Let me say P of Ck, x1, x2, xn. Can I write this one like this? P of Ck comma x1 comma x2 comma so on xn. Can I write x1, x2, xn comma Ck?
Yes.
Why? Why? Because P of A intersection B is same as P of A comma B. P of A intersection B equal to P of B intersection B. That is P of B comma A. A comma B is same as B comma A. In intersection, that is commutative. Intersection isn't it? Is it not commutative? Order doesn't matter if you take intersection. Therefore, this can be written as P of Ck, x1, x2, xn can be written as x1, x2, xn, comma Ck. Can I write something like that? Yes. Just wait for a few seconds. Yes. Yes. Now, let me go to the basics. Here, what am I doing? There is something like I will apply chain rule and conditional probability. Just see this one. Yes. Take 1 minute time and give me justification for this particular step. I am writing P of x1, x2, xn, comma Ck as P of x1 given x2, xn, comma Ck, P of x2. How am I writing? Just, my dear friends, just concentrate. Let me recall, let me go to the basics. What is P of A by B? Conditional probabilities, P of A intersection B by P of B. Can I write P of A intersection B equal to P of A given B into P of B? Yes. Yes, P of A comma B, can I write P of A intersection B? I can write. Which can be written as P of A intersection B into P of B? Yes. Now, let me say this x1 is A. This x2 to, yes. Now you must say. How am I writing this one? Can I say this entire thing is B? Can I say this entire thing is B? Is it not P of A comma B? Yes. Which can be written as PA given B into P of B. Is it not that application? P of A given B into P of B. Just I am applying conditional probability. I am applying conditional probability, I am applying Bayes' theorem repeatedly. If you keep on applying again, same thing. That's what, just and we keep it as repeated applications of the definition of conditional probability. This is repeated applications of conditional probability. Repeatedly I am applying, isn't it? If you keep on applying, I will get this something like this. There is something like conditional independence. What is that conditional independence? There is a simple definition for conditional independence. The same thing, just I am applying. It's not. Just let me say. Just give me one minute time. Just what is conditional independence? There is one simple definition. I think I might have written somewhere. Let me check whether I wrote or not. One minute. Actually, initially I have shown what is independence. There is something like P of A by B is equal to P of A. Is it not independence? Is it not independent? That's what we discussed. For two events, let me say it like this. P of A given B comma C. Again, is it conditional independence? You are just removing B. It is not, it is independent of B. But what is the difference between this and this? This is conditional independent for two events. This is conditional independent for three events. Isn't it? Why? Because B is not making any difference. Just here, what am I doing? P of xi. Yes, just my dear friend, just see this one. P of Ck. This is a. I will conclude. Just wait few minutes. P of Ck given x1, x2, so on, xn is proportional to. This I have shown. Not this one. We remove denominator. Few minutes. What is this? Just is it P of Ck by x? What is this P of Ck by x? Probability of Ck given x. Ck is a class. X is a. What is x? X is vector. This can be. Can I remove this P of x? That's what I told. K equal 1, 2, 3, 4. If you keep on doing, it will not. Denominator is same. In that case, what I have to write? This can be, this P of x by Ck can be written as P of x intersection Ck by P of Ck. These two terms will get cancelled. You will get this term. Isn't it? Anyway, this can be written as, if I remove this one, this can be written as proportional. Is it not? That's what he did here, just see. P of, just see, Ck by capital X. Capital X means x1, x2, xn. He is removing denominator and keeping proportionality. Yes, this is, if you have any difficulty, please ask. These two terms are same. P of Ck into P of x by Ck is same as P of Ck intersection x. They are same. Just Ck intersection is same as P of a comma b is same as P of a intersection b. That's what I am writing here. Just this particular term. Just now we simplified this. Whatever we did for P of Ck x1, x2, xn, just I am keeping here. Just I derived a formula. This is the formula. This is simple formula. Maybe you have to sit for a few minutes. If you sit for a few minutes, you can understand. It's a simple mathematics, simple probability. Anybody just go through it so that you can understand. It is something like, let me say, for example, I need probability of x1 given features x2, x3, xn, comma ck. Let me explain this with simple example. Let me say probability of x1. x1 means feature 1. Let me say weight. Probability of a person whose weight is 180, 180 kgs. Is it? Yes, let me say there are people like obesity. There may be people like fit. There may be people like lean. How many classes are there? 3 classes. Means my classifier after feeding few features, if I feed few features, my classifier must say whether that particular comes under obese, that particular person comes under fit, whether particular person comes under lean, that must be the case. For which what am I doing? My feature 1 is 180 kgs, let me say. Hair length is black color, hair color. There are some features, eye color and some sort of whether he belongs. I have to build a system. But calculating all these things very tedious, very cumbersome. You cannot calculating these things is a little bit difficult. That's why we simplified all these things into simple formula. How it works, why it works, we will see. Just give me 1 or 2 minutes time. Yes. That conditional independence, we already discussed what is conditional independence. What is conditional independence? Just xi, P of xi, given xi plus 1, comma so on xn, comma ck is P of xi, comma ck means what? You are not carrying this particular part. That is known as conditional independence. That's what we discussed. Conditional independence means what? P of a given b comma c is equal to P of a by c. Yes, just that assumption that database means what? There is a conditional independence of each feature pair. Yes, let me take one data set so that we will try to understand. Yes, there is something like argmax. Argmax means what? You might have heard this argmax many times in your programming language. You have to find this value for k equal to 1, 2, 3, 4. Whichever maximum number you will get, that you will choose. That is argmax, isn't it? Anyway, let me take one simple data set. Yes. Just take 1 minute time. Just observe this particular data set. In any AI textbook, you can find this particular. In any standard machine learning textbooks, any standard machine learning or any standard AI textbooks, you might have seen or you will see in future classes. Since what we did till now, since we learned theory of naive-Bayes, let's try to apply it to a problem so we can understand better. this is this is a blog. What is this blog? My dear friends, please silent. Shorterline.com. Just go to Google and type shorterline.com, where you will get this particular data set. What it is, we will try to understand. This is one. This I can say. This is the blog which explained this particular algorithm, this particular probability concept, this particular statistics concept so beautifully, so beautifully. Just type in Google, just say this he explained very nicely. It is very nice explanation. Here it is, he explained very clearly how many features do we have here. Here we have how many features we have here. This is a particular data set. What is the size of this particular data set? We have 14 days data. Day 1, day 2, day 3, day 4 till day 14. How many days data do we have? 14 days data we have. And what are the features here? We have feature for outlook, we have feature for temperature, we have feature for... How many features are there? There are 4 features. Feature 1 is outlook, feature 2 is temperature, feature, this I think feature 3, yes. Feature 3 is humidity, feature 4 is wind. What is this one? This one is, what is this? Class. How many class are response variable or class variable? Yes. How many classes do we have here? We have only 2 classes. That is, this data set is related to binary classification. This is he said. Well, what it says, play equal to yes, play equal to no. If you give some query point, your algorithm will say whether to play or not to play. It is something like if you feed some email, your algorithm will say whether it is spam mail or not spam, isn't it? But it doesn't mean this particular algorithm will perform only binary classification, my dear friend. That's what we discussed. You can perform multi-class classification for that matter. This is algorithm, this naive-based algorithm, which has beautiful applications in machine learning, in artificial intelligence. There is a beautiful concept known as feature engineering. This is the algorithm which plays a crucial role in selecting good features. Anyway, I don't want to deviate from this discussion. Time being, just let me say, I have a data set with 14 days data set. Now what I have to do, let me understand each feature. First feature is outlook. What are the possible values for first feature? Sun is one value, forecast is another value, rain. I think this feature has got 3 values. Which feature has got 3 values? Outlook feature has got 3 values. Even temperature is a feature. What are the possible values? Hot, mild, cold. Therefore, this has got 3 values. Humidity is high is 1 value, normal 2 value. How many values? 2 values. In similar manner, I have feature 4. F4 wind has got weak 1, strong 2. That's it, 2 values. Yes. Well, let's try to understand this. This is the data set. We have 14 days data set, and your response variable is to play or not. How this particular algorithm how can we apply for this? How can we apply our probabilities, posterior probabilities, prior probabilities, evidences for this particular one? What you have to do? Just let me say 1 or 2 words here. Let me say I want to compute what is my intention here. Here, if you observe, what type of data it is? It is categorical data. Hot, mild, cool. Is it categorical data? It's a category, isn't it? Even sunny, overcast, all these are categorical data. But means understanding some probability, understanding some statistical techniques with the help of categorical data is very easy. This doesn't mean this particular algorithm works for categorical data. It can work for all types of data. As I told you, this is a problem at hand. For every problem, there is a stage known as training stage and testing stage. In machine learning, in artificial intelligence, whether it is a robot agent, whatever it may be, first you have to train things, isn't it? Why do we need data sets? There is something like, maybe, I think you are in first year, yes, there is a long way to go. In future, certainly, maybe you have to hear these two words, training, testing. Anyway, you will learn those things in detailed manner. Time being, let me say like this, these are the features for F3 and 4. After that, now, as I told you, these features are F1, F2, F3 are categorical features. This classification comes under which classification? It is binary classification. That's what we were saying, isn't it? Training stage, first you have to train the system. First you have to detect whether spam or not spam. First you have to train the system. In similar manner, whether to I have a query point x cube to check whether I should play the tennis or not play the tennis for that matter. First I must train the system. Yeah, for training what I need something like some data set. How it works we will try. Let's not forget what is the task. Our task is probability of the class label. Here what you have to find. I have to find probability of class label. P of class, let me say play equal to yes given query point x cube. Even I must also calculate P of class play equal to no given query point x cube. I have a query point. Let me say I have a query point. For that query point, I have to calculate two probabilities. Yes probability I have to calculate. No probability I have to calculate. Whichever is maximum. If I get no probability is more than yes probability, I must say don't play. If I get yes probability more than no probability, I can say play. That is known as argmax. What is argmax? Argmax means I will find all possible values, who are maximum value. I will vote for that one, something like that. Anyway, how will it be? That is even people in the literature of machine learning, people used to call it as map. What is that map? Maximum a posteriori method. There is something standard terminology. That maximum a posteriori method, people used to call it as maximum a posteriori method. How it works, we will see. Just let me take, just give me 1 second time. Yes, what it says, P means probability, play equal to yes, given query point x cube. P means probability, play equal to no, for given query point x cube. Your x cube means query point. Your x cube belongs to y cube, play equal to yes. When can I categorize it is play equal to yes? If first one is greater than second, then I can consider it as yes. Anyway, this is the, just observe this one. Actually, if you want to understand this one, you have to go back to previous slide. So what is your data set? There is data in that data set. Let me go back, otherwise yes. In this particular data set, what is the probability? P of C equal to yes. What is the probability for yes? What is the probability for yes? 1, 2, 3, 4. How many are there? 9 by 14. Total 14 is data set. In similar manner, we have C equal to no means what? 5 by 14. There are only two classes, no? Isn't it? There are only two classes. In similar manner, just if you want to understand the training phase, first I am building training phase. First, you must have an idea of this particular data set. I am calculating probabilities, likelihood probabilities. For example, just see this one. Let me write one statement here. P of outlook. Do you have outlook? Yes. What is outlook? It is a feature. Outlook equal to sunny. Does it have sunny value? Outlook? Yes. P of outlook equal to sunny. Given C equal to yes. Can you guess this probability? Is there anyone? Someone says 5 by 14. 2 by 9. Who says 2 by 9? 2 by 9. Please justify once. Yes, silence please, silence. Yes, it's correct. 2 by 9.
2 by 9 because first we need to, the outlook should be sunny and also the class play should be yes, sir.
Yes.
So the total number.
Class label yes means this one. This one.
Class yes, sir.
This one. This one.
Not all. The along with that yes, even on first we need to consider all the class labels which are yes, sir.
Yes.
And
how many are there?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
9, sir.
Okay. What is he saying? Please listen. Why? Because once if you understand this one, there is nothing in your naive-based classification algorithm. All remaining probabilities are just simply, he is explaining. What's your name? Yes, Ashok, please treat me just like 5th class student and explain.
So now we have all the like total number of observations, like they are 9, sir. Like all the yes are 9, and now we need to find out how many sunny out in the outlook column. We need to find out how many sunny are there, which are also yes.
Will it come? This one?
No, sir, because the class place, the class label is no, sir.
Yes. No. No.
So
This, will it come? Outlook equal to sunny.
No, sir, because we need to only get sunny, sir.
Yes, this will not come. First one. Let's break one by one. Break. No.
Overcast, no.
This one.
No, sir. It will work.
Yes. Next.
Yes,
These are known as likelihood probability factors. Yes. This. Okay. Is it 2 by 9? Yes. This is likelihood probability. Just what you have to do? It's not miracle. It's not a big thing. It's not a big deal. I calculated. What is this? What is this? 2 by 9. What is this 2 by 9? P of outlook equal to, this is outlook. What is outlook? Outlook is a feature. How many features are there? 4 features. Let me go back. Outlook is feature. Temperature is a feature. Humidity is a feature. Wind is a feature. This is the given data set. Now I'm training the system. We are training the system in the sense calculating probabilities. Why do I need these probabilities? I already discussed mathematical background behind it. Already Wikipedia page we discussed. Now what we calculated here, P of outlook equal to just what it says something. Given what is the condition? C equal to yes, which is equal to 2 by 9. In similar manner, this is the case. This is 2 by 9. In similar manner, can I calculate P of outlook equal to forecast? Given C equal to play equal to yes. If I calculate play equal to yes, I can also calculate for play equal to no. Isn't it? But how many possible values for outlook feature are there? 3. What are they? Sunny, overcast, rain. For all of them I can calculate. For all of them, there are how many S's? 9. How many no's? 5. These are the likelihood probabilities. How he explained. What is your name? Ashraf. Okay. My dear, so let me say, my friend explained. I don't want to. As our friend explained, just you can apply the same procedure for what? For outlook, for temperature, for humidity. Can I apply? Yes. That's what we did here. Just you have to calculate all probabilities. Yes. P of C. What is our mathematical background? Probability of C given 4 features. What are the 4 features? What is my F1? Outlook. What is my F2? Temperature. Yes, side. Window to window chest. Yes. Now I depending on all these. Yes, side. Depending on all these features, I must say its class. What is my class? Tennis ఆడాలా వద్దా చెప్తున్నారు. అది ఆడమంటే ఆడాలి లేకపోతే that is the classification system. For example, let me say like XQ means what? XQ means query point. XQ means query point. Initially, in Wikipedia page, we were saying that x1, x2, so on, xn, n-dimensional vector. That is x2 or x, whatever it is. This is first feature. This is x1, x2, x3, 4 features. I have 4 features. I have a query point. I have a query point. I have a query with how many features? 4 features. Now I must say, just let me take one simple example. This is the mathematics which I already discussed. I don't want to bore with so much of mathematics. I gradually realized that don't teach too much maths, too much mathematics. But anyway, that I think you must have an idea. You must have feel that there is real applications of conditional probability. Just see, that's what we discussed. SS9 knows 5. Yes, my dear friends, I have a query point. What is my query point here? XQ query point. XQ in that particular shorterly log in that particular block is saying x dash. What is my query point? Sunny. What is this first sunny means? Whose value it is? Outlook. My outlook value is sunny. What about next one? Temperature. Temperature value is cool. Outlook value is sunny. Temperature value is cool. Next one? Humidity value is high. Next one? Wind is strong. 4 features. For each feature, they gave values. My dear friends, I have a query point with sunny, cool, high. Outlook is sunny, temperature is cool, humidity is high, wind is strong. Now, you have to tell, your algorithm must tell, your classification algorithm must tell, will you allow it to play or not? What can I do? What I have to do? Just see. What I told MAP. MAP means maximum priori method procedure. Maximum priori means what? There are so many probabilities. Which one you have to choose? Maximum probability. That's what it says. That is what that particular block says. MAP rule. How many probabilities I have to calculate now? 2 probabilities I have to calculate. Yes. One is yes probability and another one is no probability. Isn't it? How can I calculate? Just see. It is simple. It is simple and straightforward. P means probability, class, play equal to S, given x dash. What is my x dash? This is my x dash. This is the given query point. For this, yes, silence please. For this particular query point, I must calculate yes probability. What is the, how can I calculate? We already discussed mathematics background, mathematical background. That is the formula. P of Sunny given class play equal to S. Isn't it? Sunny, first one is Sunny only. Into P of outlook value is Sunny, temperature value is cool. Next, humidity value is high. Next, wind value is given condition is into P of class label is yes. That's what I discussed in that Wikipedia page. How you may ask me, how do you know this formula? That was the mathematics background behind it. Now we already, how do you know this 2 by 9? How do you know this 2 by 9? Our friend already explained. In that manner, all these probabilities are known as likelihood probabilities. These probabilities are basically likelihood probabilities. If I multiply them, if I calculate what is the value, 0.0053 for which, for yes or no? It is for yes, isn't it? In similar manner, we can also calculate what is our intention. You need to say why you are taken. Yes or no, you call life array. You must say yes or no. Depending on x cube, I must say y. For yes we calculate. For yes we got 0.005. In similar manner, can I calculate for no? This is something like which I have shown. P of F1 given C, P of F2 given C, P of F3 given C, P of F4. How many features? 4 features. F1 means F1 value. F1 value is Sunny. First feature value, second feature value, third feature value, fourth feature value. It's class probability I must multiply. Isn't it? Yes, what about this? No probability given query point x dash. Same in similar manner I can calculate. Can I calculate in similar manner? What is the value? 0.0205. This is probability for no. Earlier one probability for yes. I think that after point we have 2 zeros. Here 2 zeros. Here we have only 1 zero. Means which one is bigger? No is bigger. Means according to that query point, please don't play tennis. How do you know? There is a training data set. Already 14 days data set is given. Depending on it, we calculated likelihoods. Likelihoods means we calculated probabilities. Just we applied something, we derived something, and whichever now give any query points with that 4 features from here onwards. Just give any 4 values related to that 4 features. Your name base will tell whether to play or not to play. It is in that similar manner. In similar manner, we can build. What we can build? For that matter, any classification task we can run. This is. I explained this particular algorithm with some categorical data. But of course, this is a heterogeneous class. Everyone may have their own background, some people may not interested in mathematics, some people may not interested in probability, some people may not interested in application, but this will give some sort of flavor. Isn't it? If you are really interested, actually I recorded lectures in detailed manner on this particular, other than maybe 10, 20, 15 lectures I recorded. Just go through it, understand it. This is spam filter. You can build same thing, spam filter. Just you can check whether your email is spam or not spam. Isn't it? You can yes, there is something like reviews, sentiment analysis, positive review, negative review analysis. You can make use. If there is some classification task, certainly you can apply this particular algorithm. I request all of you, being students of this particular this particular branch, it may take little bit time. But if you sit and understand real mathematics and statistics behind it, certainly people will appreciate it. If you go for an interview, if you explain some sort of maths, and unfortunately many of us used to fail in maths part. But it needs little bit patience. But if you have little bit patience, but that's what there was a stage where I would like to spend much time, but I sense that maybe few of me not that interested. But maybe certainly I can find 5 students in this group. Certainly I can find 10 students in this particular class. Just work on that simple maths. Certainly you will be different from others. Even you can classify the text based. There is something like maybe this but according to your syllabus, there is I have not seen text based classification. But you can always apply for sentiment analysis, for text classifications. But in order to understand that text classifications, you need a little bit knowledge on stop word stemmings and grams. We will see time being just understand this is all these are applications of our famous algorithm, name-based applications, name-based classification algorithm. There is something like smoothing techniques you can apply, but don't be in hurry. As of now, just understand. These are one of the important concepts in machine learning and artificial intelligence. There is something like stability problems, where you can understand all those stability problems. Actually, if you speak strictly in this entire machine learning or artificial intelligence, I can say it's a game between overfitting and underfitting. Yes, those things, just start journey with small things. Later you can make big things. I want to show there is much scope. This is a big area. This is one of the best algorithms. This is one of the best concepts. Even just I have seen your syllabus that related to statistics and probability. Every concept I covered as a part of this algorithm. Just if I define something, it may not give pleasure. Just why I included, I kept as we discussed with simple data set, something like some sort of mathematics. At least just try to understand 40 to 50% of these things. But all these are not important. This trade-off things, bias and variance trade-off things. Why? Because you have enough time. You are just used. I think, as per my understanding, you just started your journey. In future, certainly you can do it. Yes, that's what I'm saying. Feature importance. There is importance. Feature importance means what? Yes, you can apply this particular algorithm for feature engineering. Features means what features, if you want to work on particular data set, there may be so many features. On which features you have to work. This algorithm is useful. What you have to do? For all features you have to calculate probabilities. Which features is getting higher probable? What is that feature? That is known as feature engineering. But I am saying in simple words, but it is That is something like this feature importance. This term says feature importance. This is machine learning or AI. This feature importance is one of the important concepts. Feature engineering is one of the important concepts. Is it? Feature importance and interpretability. There is something like data sets. Yes, if you want to find outliers, what is outlier? What you heard about this term, outlier? Which is a little bit different from your regular feature, isn't it? Some person is so high, has so much of height, it's a little bit outlier from this. So sharp. We can detect outliers with the help of this this particular algorithm, this particular yes. Yes, that's what I would say about reviews, text classifications. Yes, this is one scikit-learn. Do you know what is scikit-learn? Yes, even in Python you might have learned about scikit-learn. Yes, this is the web page. Just see. My dear friends, this is the scikit-learn.org. Name base HTML. This is the web page name. In scikit-learn 0.24.2. Just see, we have something like Gaussian naive Bayes, multinomial naive Bayes, complete naive Bayes, Bernoulli naive Bayes, categorical naive Bayes, out of 4 naive Bayes. First, if you know what is naive Bayes, you can make miracles. Isn't it? In Python, the beautiful thing in Python is, one of the great thing in Python is, so many machine learning algorithms, so many algorithms, so many artificial intelligence related algorithms. They implemented only with the 4 to 5 lines. That's it. For example, just say KNN algorithm. You can see 4 lines to that's it. For example, if you want to understand support vector missions, you can find only 4 to 5 lines code. That's it. Everything is implemented end to end in Python. That's the beauty of Python. For example, this is a page you might have learned about scikit-learn, where you can find different machine learning algorithms implementation. There is something like Gaussian naive Bayes. You might have learned about Gaussian distribution. Have you heard Gaussian or normal distribution? Yes, normal distribution. I think if you, maybe in the next course you may get it. Somewhere you will get it. Even on probability textbooks also, there is a bell-shaped curve. That is Gaussian distribution, that is normal distribution curve. That's what it says. You see, first one, Gaussian naive Bayes. You can apply Gaussian distribution, you can combine Gaussian distribution with naive Bayes, which has got so many applications. But you can find rarely people, there are very few people who are really working on all these areas. As you are so youngsters, you are just entering into the system, you have got so much of advantage. If you work with delta x, you will get x cube result, e power x result. If you work delta x, that will impact at exponential impact. Why? Because we are not having that many people who are vigorously working in these areas. Maybe I can say sky is the limit for you people. Maybe ఈ భూ ప్రపంచం పుట్టిన దగ్గర నుంచి మీ అంత అదృష్టవంతమైన పిల్లలు ఉన్నారని నేనైతే ఎవరు You are the luckiest generation on the earth. Why? Because we don't have these type of opportunities. Even maybe our friends, our colleagues, may agree with me. Just explore things. Just explore things. Suddenly, you will understand things. Yes. Thank you so much.
Any queries? You ask, very. You ask. They don't have any queries.
నేను మీకేం చెప్పనా మీరే మాకు చెప్తారు. ఫస్ట్ సెమిస్టర్ కంప్లీటింగ్ ఫస్ట్ సెమిస్టర్ only one thing. These subjects are very good subjects. Try to work with some sort of passion. We are seeing people are getting. I'm shocking or seeing passion. Yes. One of my students got 97 lakhs. 97. The problem is, yes, I asked her, actually I taught, there was a student last year, now she is in US. I taught her one subject known as formal language and automata theory. In fourth year, somewhere I have seen her somewhere in our campus, I have seen her, I asked her, what is your secret? Always success always gives some sort of clues, isn't it? If somebody is successful means always you can find some sort of clues. I asked her, what is your?
So, we all know what is fuzzy set, okay? So, if you don't know, just I give you some explanation. And what is importance? So, where we use fuzzy set, okay? And the second one, so, see, I try to expect some silence. If you speak continuously, it's completely disturbance. So the second one, I try to explain what is fuzzy offset. Probably you people don't know what is fuzzy set and fuzzy offset, but I try to give some introduction about these concepts. Okay, these are the basic things to handle uncertainty. My topic is on uncertainty handling. So in a fuzzy offsets, so there are some concepts. One is like similarity value, fuzzy influence value. So to define these two, we use some fuzzy membership function and weighted membership function. Okay. So then finally we define a fuzzy similarity matrix. And what is the definition of fuzzy offset? Which is defined based on all these concepts like influence value and membership function and weighted membership and fuzzy similarity. Okay. So how do we handle uncertainty? So that way I will explain one particular measure that is also my own measure I defined, that is called fuzzy of entropy with example. Right? How to handle its uncertainty with example I will show. And in general, one architecture that is called self-organizing map. So this architecture, how do we integrate this self-organizing map with fuzzy offsets? Okay, to define a new model. So that also I will show you. Okay, try to understand. So these are some advanced things, but Try to understand. And application, what is the use of this model? So clustering. So I will show you some results of clustering. So these are the concepts or outlines we can say. So I try to discuss. Look at this diagram. So the last one, see I tell once, again I don't want to repeat it again and again. This is not the thing. So if you don't understand, just ignore and sit like without talking. So what is the definition of fuzzy set? Look at here in this diagram. So a black, I take XY plane. So there are some values of X, right? So these are the simple objects, we can say are samples. Those are from, like you take 100, that is called M. Okay, in mathematical notation we can say some I equals to 1 to M objects. And each object has a certain membership degree. That degree lies between 0 and 1. Okay. So look at this diagram, it's like a simple bell shape, right? So each object has one membership value, and if you plot all the membership value, the shape is like this, right? And the membership values lie between 0 and 1, right? So this is called fuzzy set, or we can say membership function. So this is characterized by one simple notation RA of Xi, right? So X is Can you hear me?
Yes, sir.
Back clock. Okay, now? Okay, fine. Now you see this diagram. So the entire membership function is characterized by simple notation R, and a subset that is called A, and Xi number of attributes or samples, whatever we can say, right? Say for example, we are all objects, each person has one membership value. So if you define all the membership values in this diagram, so this is the basic definition of fuzzy set, right? So if you read the text here, a fuzzy set is characterized by a membership function. So just now I explained what is the membership function. So the membership function means, so the values you get a for each object, and if you plot the values in the diagram, it looks like a pi membership function, triangle membership function, right? Depending on the shape, we can say that is triangle or pi, whatever. So the objective here is mainly to give a membership value of a particular object, right? That value lies between 0 and 1. That is all. Fuzzy set. So if you take set of collection of membership values, that is represented by a fuzzy set. So as I mentioned previously, look at there are 3 types of membership functions. One is triangle, second one Gaussian, and pi membership functions. So here I mention only the diagrams. If you type triangle membership, you will get the actual equation of triangle membership in the Google. Okay, I do not mention all the things. These are the basic things. So whatever the input value we send it to this function, the shape looks like triangle. So input value means number of objects, a set of objects. And if you take Gaussian, we all know what is Gaussian, e to the power of minus x minus u by sigma, right? That is the equation for Gaussian. and similarly pi membership function. So the objective here is there are three different functions, and if you want to triangle shape membership function, use triangle pi for the that membership function. And if you want Gaussian shape, use Gaussian membership function. Similarly, pi membership function. Okay. So this is the basic concept of fuzzy set. So given an object, what we do, we just assign a membership value that is between 0 and 1, right? Any value between 0 and 1, either 0, no problem, or 1, no problem, at 0.5. Whatever the value you want, so assign that membership value depending on the equation. So next, based on the fuzzy set, we define fuzzy relation. So in fuzzy relation, there are two sets. So in general fuzzy set, only one set, that is a set of objects. But in case of fuzzy relation, there are two sets, A and A, or A plus B, right? So we take two pair of objects and we assign a membership value between 0 and 1, right? So look at this equation, a simple equation. We take x1 and x2. x1 from one set, x2 from another set. So the fuzzy relation R of x comma or x1 comma x2 is 0.5 something or 0.6 something like that. x1 and x2 belongs to a set A or two different sets A and B, right? So the relation, fuzzy relation, we just represent in this way, right? So that's all. Here R of x1 comma x2 is a membership value that is based on any membership function, right? Like triangle or Gaussian or pi or any other membership function we can use and get a membership value per pair of objects. That is a fuzzy relation. Look at here, I just explained some fuzzy union, fuzzy intersection, right? You all know what is union and intersection, like set T, A intersection B, A union B. So if we take a set A and B, and each object x1 has one membership value 0.1, and x2 another membership value 0.9. So like that there are four objects. I take only four samples, and each sample has one membership value between 0 and 1. Right? Similarly, I take another set B, and each object has one membership value like 0, 0.1, 0.9, like that. If you plot these two values, so here I chose triangle membership function, you get a membership value of a particular object x1. So if you see here, so this is one membership, type triangle, and this is another membership function, triangle A and B. So this is, there is some overlap, right? So when you take A union B, right, this overall thing you will get it. And intersection is this one, right? So take overall A, this is the shape. And when you take only intersection, this is a small triangle, we can get it. So based on these two sets A and B, right, one is union and another one intersection. So these are the basic things, and we see another fuzzy logical operators. Okay. So these fuzzy logical operators generally used to define some particular membership function, right? Look at problems multiplication and another one here. So there are two standard fuzzy logical operators. Do you know what is logical operator? Right? Can you give me example what is logical operator? So R gate, AND gate, right? So like that here, fuzzy logical operators if we take, so the value is 0 and 1, right? Two class, either 0 or 1, no membership in case of logical operator. So if you take multiplication operator, you take 0, x1 and x2, 1. So then we just substitute two values. So for example, x1 is 0, x2 0. So here 1 minus 0 plus 0, right? So that means here x1 is 1, and 0, comma, so 0, comma 1. So here 1 minus 1 plus 0, 1. Hello. So you take 0, x1 is 0 and 0, then you will get it 1. And x1 is 0, x2 is 1. So then here 1, 0, comma 1, meaning value 0. That means 1, 0. So whatever logical table, right? So if you apply here this multiplication operator, that should satisfy the property of this table, either 0 or 1. So similarly, if you apply TNR, so here the operation is maximum and 0, comma x1 plus x2 minus 1. So why I am saying here, we can also define some sort of logical operators where we take x1 and x2, 0 or 1. So whatever the values you take 0, 0 and it should satisfy the condition of this one. So, see, if you are not interested, anyhow, I don't want to waste my time. I just know this. Okay? Unnecessarily, people are inviting me. Shall I go? Or if you are not to continue, continue. I don't have any problem. I can leave. So these are the simple logical operators. So one is multiplication and another one norm operator. Okay? So the property it should satisfy these two tables. So based on these logical operators, we can define a notion of fuzzy object. Look at this diagram. We take all xi. Xi means number of samples or objects, 1 to n. And this black, some sort of black curve here is it, that is the membership function. For that, we need to define one lower membership and one upper membership. That means if it is an object, so it has two membership values. One is lower and another one upper, right? So to characterize a set, fuzzy set, so we need two types of membership values that belong, the membership values belong to lower and upper approximations of a particular set. So that means for every object xi, it has a lower membership and upper membership. If you take set of objects xn, so all the objects have some sort of memberships belongs to lower and upper approximation. That is characterized by fuzzy set. Look at, there are three definitions I explained. One is fuzzy set, and the second one is fuzzy relation, and third one fuzzy set. When we compare all these three definitions, fuzzy set is simple one membership for a particular object, and fuzzy relation is set of pair of objects. So pair of objects should contain one membership value. Whereas fuzzy set, one particular object has two memberships. One is upper membership and lower membership. Right? So these are the differences. So initially fuzzy set is introduced, then fuzzy set is recently introduced. Recently means last 10 years or 15 years before. So use this concept of fuzzy set, that means lower and upper membership value of a particular object, and we define a similarity relation, right? So here I use a membership value. This is a function of membership function like 1 by 1 plus exponential dk w1. So what is dk here? So the formula is given an object and you take the difference from the mean of the entire set. So mean is set of samples, right? So and similarly standard deviation, and calculate this and substitute here, and 1 by 1 plus this value gives one membership value. That is called actual membership. Use this actual membership and we define some weighted membership. That is called given a membership. Again we need to improve that membership. That is called weighted membership. How do we define that? So, for example, we take these are the two sets, C1 and C2 are two classes, and we have a such type of membership, like one is triangle, another one is regular something. Okay, depends on the formula, we get a membership values like this. So what weighted membership means? So the actual membership into weighted distance, right? So what is weighted distance? So this one, you will see what is weighted distance. Actual membership is this one. So MKI, right? So this is the distance used here, we get actual membership. Now again, to define weighted distance, so based on the weighted distance, we define weighted membership, which is inversely related to actual membership, right? Two types of membership we define. So for that, I define one particular influence value of a particular class K. So for this entire class, so we define an influence value. What is this influence value? Just it changes the membership of a particular object in this class. Similarly, another class. So this is the simple equation. We take particular influence value of a particular class A, right? So here, similarly, if you go inside, so you take an object xi of a particular class A and mean value difference between these two whole square and exponential. This is the actual membership value and this is weighting factor. And then we take sum of all the classes. So this is into power of MKI, right? And some weighting factor. So finally we will get one influence value for one class. Now use this influence value. What we do, just find similarity value between a pair of atoms. Right? This is a simple equation, like if you take x minus y plus standard deviation of a particular object, by divide A of lambda k. A of lambda k is the standard deviation of a class. Like if you see here, so for this particular class C1 we define standard deviation, and again another class we define standard deviation. So use those two standard deviations and we get similarity value. So for this similarity, based on this value again, we substitute here, we finally will get similarity relation between two objects. Right? Let us see one example. These are the equations to define a particular similarity. So for example, if there are n attributes, do you know what is attribute? So if you have a data, simple iris data, look at that on Google, there is an iris data, so real life data. So there are 50 samples class 1, another 50 samples class 2, and another 50 class 3. Like there are 3 classes and 4 attributes. So if you take the data, we need to define 4 similarity matrices, and based on that, so we define Fuzzy object, right? So if you look at this equation, so we use implication operator that previously we have defined. So, and this is the similarity matrix, and this is the decision classes of a particular object x2. Similarly, x1, x2, x3, for every object we get one law of approximation. Initially I have shown a diagram, right? So this is the equation for finding a law of approximation of one object, x1, x2, x3, like that. So here the first equation is similarity matrix, the second one decision attribute. Decision attribute is simply giving for a decision value, right? So after approximation is like similar way. Simply the equation is like here we use C now, not implication. So for a particular objects we get similarity matrix, and that particular object we get a decision value. Substitute in this equation, finally we will get a membership value that belongs to upper approximation. So finally what we do, Fuzzy log entropy. This is the equation we need to define to approximate or to handle uncertainty in a particular class, right? So look at this equation here, the sum of actual membership into lower membership of objects in a set C1. If we take class C1, okay. So what is lower approximation? In this equation, sum of actual memberships into lower memberships of objects in the set, and upper approximation is sum of actual memberships. In the previous slides, I have shown what is actual membership, right? And upper memberships also we have shown. For a given object, we have two memberships, one is lower and upper. So this is the sample of channel entity. You substitute this value here, you will get entity value in terms of fuzzy, right? This value close to 0. So the small value of FRE, that means fuzzy of entity, indicates so the cluster compact. So I will show you an example. What is that? See, look at here, there are two classes and 6 attributes. 6 patterns or samples. And there are 3 attributes, 1, 2, 3. I am giving a real life data set example. So 3 attributes, and these are the decimal classes 1, 2. So that means the first 3 objects belong to one class and second 3 objects belong to another class. Right? And if you plot those membership values, you will get the diagram like this. So, this similarity matrix for attribute A1, look at this similarity matrix, all diagonals 1, and this lower and upper triangular matrices are same. Okay, so how do we define this? Just now I explained some equations, right, for this similarity equation. So, use that equation and we get a for this similarity matrix. And you compute lower and upper approximations like using these two equations. This one for upper and this one for lower approximation. So here we get for a particular class C1, these are the membership values, lower membership values. So there are 3 objects X1, X2, X3, and similarly for class 2, there are 3 membership values that belong to upper approximation, right? So actually in the 2 classes there are 6 objects. So for all the 6 objects, class 1, those all 6 objects are from 2 classes, right? Class 1 and class 2. So these are the first 3 from class 1, the second 3 from class 2. And this is the lower approximation of class 1 and upper approximation of class 2. Similarly, we define lower upper approximation of class 1 and upper approximation of class 2. So use those 2 and we define this FRE, fuzzy of entity for C1 and fuzzy entity for class 2, right? So look at this final value 0.1535 and here 0.1390 for class 2. So when I compare these 2 values with some other entity, so other entity is some one paper published here, that one 0.1589, 0.4497. So when you compare these 2 values, the present one, FRE is 0.15, it is lower than this one, 1589. So that means it gives you some better values than the existing one. So that means lower FRE is better handling of uncertainty, right? Significant. So in this way, we just handle we handle uncertainty in a particular set. Now, this is the simple concept of uncertainty handling using fuzzy of entity. Okay. Now let us see one paper, granular self-organizing map or clustering microarray. Okay. So you all know what is self-organizing map? You don't know. So anyhow, that's why I said these are some advanced topics. Anyhow, try to explain what is self-organizing map and how do we integrate these two. This fuzzy offset with self-organizing map. So what is that? This diagram, given input data and we get use self-organizing map, we get some output clusters and we use fuzzy offset theory, whatever the fuzzy offset theory we discussed so far, and define a new neighborhood function, right? This self-organizing map uses one neighborhood function and that we define using fuzzy offset theory. And the entire model we call granular self-organizing map. Okay? And how do we use this granular self-organizing for clustering some data, real life data, whatever the data like IRIS or microarray or any data. Right? If we take some satellite images, that also we can cluster number of regions. So we can apply this model to do clustering of a particular classes or groups, whatever. So here I mainly my contribution. See, whatever I discussed here, these are all the my own topics. Okay, not from the so here I define some commission rates of self-organizing map. And this is the structure of one neural network, self-organizing map. Within this network, there are n attributes, and number of classes. So, for example, I want to class each two classes in output layer, and if you want 4 clusters, it is 4 nodes in the output layer, right? So, like that, we initialize some weights by defining these weights using fuzzy offset concepts, right? So, given this architecture, what we do here, just we need to define an initial connection weight, right? So, that weights we need to initialize between nodes in the input layer and output layer. So here I mentioned number of nodes in the input layer equals to number of attributes or number of features. For example, as I mentioned previously, if you take IRIS data, so there are 4 attributes, length and width, petal or sepal, right? If you look at it in Google, you can see the what is IRIS data. It is simple data, so everyone can use the simple data. In that case, we fix 4 nodes in the input layer and the data has 3 classes, we put 3 nodes in the output layer. Right? If you take any number of nodes in the input layer and 4 classes in the output layer, you can count the data. It's a simple example of the architecture. And number of nodes in the input layer, number of features. Right? And see, why I am saying this architecture, generally people do projects like 4th year. So there are many existing tools in neural networks like support vector machine, self-organized. Support vector machine is mainly for classification, and this is mainly for clustering and multi-layer perceptron. Neural networks, AI, machine learning, artificial intelligence, and machine learning department, right? You all should know these are the basic concepts. Anyhow, this is mainly AI ML, right? Probably you will be taught later, okay? Not now, 3rd year, 4th year, but we have to do project in AI ML, machine learning project. So that is because this is not a computer science department. It is computer science, but a part of computer science. AI mainly specific. This is no specific comment, right? AI and machine learning. So you all should do projects in machine learning, right? We must tend to do machine learning project because once you leave this place, what project we have done in class, you should say something in machine learning because the department is AI ML. So there are many tools. You need to define a new thing, but there are many tools already available in MATLAB, Python, R software. at least you should know something like models, like neural networks, right? So for example, AI means mainly people what type of techniques you studied in machine learning. You should say like classification, clustering, feature selection, right? Semi-supervised, dimensionality reduction. There are several algorithms. So your projects you should do projects in the same domain, right? There in fourth year we have to do projects in the same domain like machine learning. So there you use all machine learning tools. Understand what I am saying? Right? So one example, self-organizing map, which is a model mainly used for clustering purpose. Right? Clustering what? Clustering is an unsupervised technique, and we need to identify groups within the data without considering any class labels. This is the project we have to do in fourth year. Since we are doing machine learning artificial intelligence course here, we have to do projects in machine learning domain. So you don't need to apply longer self-organizing because the code you will not get, but you will get it a self-organizing code in MATLAB or R software. You just type it, you will get it a code for self-organizing. And you have a data, so that also you can download the data you can download from Google and just send it to the model, you will find out clusters. Right? You know, that's all you need to study here, but I don't know what is your what are the subjects you are studying here. That's a different thing. And what is self-organizing map here? So we need to generate two number of clusters using conventional self-organizing map. So in fourth year, just why I am saying here in the fourth year when you do project on self-organizing map Google, you will get it a code MATLAB or Python whatever. Then what is the objective? You just type. You need to cluster the samples into different groups. Right? And so here, what I do, just directly take a self-organizing map and train the model. So what is the training model? So I just use the name of the training model. It's a feed-forward model. That means so it's like just send an input and get the rate and update the rate. This is the simple self-organizing map training. I have not explained here, but simply I am mentioning. And so we take clusters of self-organizing map and we define some sort of decision table. When you want to apply fuzzy offset, we define a decision table. And what we do here, just now compute similarity matrix for every attribute as I explained previously. Okay, so then what we do? So we take a approximation values, right? Use some approximation operator that I have discussed today. So you take, if the class 1 have M1 attributes, you take M1 approximation values, okay? And class 2, another M1 plus 1 some attributes up to M. So you take all the approximation values of those samples. You take the average of those numeric values, and that represents one particular class. Right? So in this way I design a model. So what is that? That is the weight values from all the input filters to one class node in the output layer. So that is self-organizing map here. Right? So from this, all the input nodes we one weight value class 1. And similarly, class 2, right? From all the input values to one particular node in the output layer. Class 3, class 4. Okay, even if you take self-organizing map, what we do is just generate some sample, random weights, and that will be the distance between the nodes and outliers. Okay, in ability, the parameters what it has, the model has, and it initially gives some initial weight, right? So then we train the model by listing some learning parameter and all the things. Values of learning parameters we need to use. Okay, you will learn slowly, probably in the next semester, third semester or fourth semester. But I'm just giving a small idea about what is self-organizing. So in this way, I reference some membership values. I display all the values between player nodes and player nodes, right? And we need to update the update. This is the equation. So in self-organizing map, also it has there is a equation to update the rates between nodes and outputs. This is the equation, right? So here I mainly define a membership value, that is the year of membership value. But in case of self-organizing, there is a Gaussian membership also, right? You all know what is Gaussian membership function. So here they apply Gaussian membership function. And train the model just by feeding some image data and get number of clusters according to the user-defined values of cluster values. So this is the simple equation I mentioned here to update the rates between input nodes and output nodes. And look at this diagram. I take one simple microarray data. Okay, look at this. This is called AML and AL microarray data. And what is uncertainty? So far what we are discussing, right? Uncertainty. Look at this diagram. There are two clusters, cluster 1 and cluster 2. And overlapping portions, right? So if you take some class 1 or cluster 1, 50 samples, cluster 2, another 50 samples, and these are the samples all in the both classes. In the particular region, you can say this pattern can also belong to cluster 2, but it actually from cluster 1, right? You can also this star or plus belongs to cluster 2. And if you take circle, the circle pattern actually from cluster 2, but it calls cluster 1 also, right? So this type of decision uncertain, right? So you cannot say this pattern belongs to cluster 1 or this pattern belongs to cluster 2. So there is uncertain. That uncertain information can be modeled using this fuzzy set or fuzzy object. So far what we discussed. And look at this. When we apply this model, self-organizing hello, just little bit. Okay, when we apply this model, either self-organizing or granular self-organizing, whatever the model, finally what is our objective? To find out number of clusters according to the user-defined value. What is the user-defined value? Here, cluster number. Right? So here I find two different clusters, cluster 1 and cluster 2. And you see here there is star value, one is star and something probability. Here the cluster center. Find weights, and you can that means cluster centers. So this is based on the proposed model, granular self-organizing map, and this is the below one self-organizing map. So when we do clustering, so this type of clusters when we obtain and find out the number of cluster centers, you see the distance between these two cluster centers, and that means this is away from this cluster center, right, as compared to these two. In this way, this granular self-organizing map gives a better result than this second one. And moreover, the pattern from cluster 2 and this model recognize or correctly identifies that pattern is from cluster 2. In case of self-organizing map, this model cannot handle such type of data. So, for example, you take a pattern circle here. So it belongs to cluster 2, this self-organizing map may identify as a cluster one. That means wrongly group the data points. So that's why we will just improve the clustering performance just by adding different concepts into that model. This is what we are doing some sort of research. Okay? But in your standards that this is not much important, but you just need what is self-organizing map. You need to understand what is self-organizing map. And you see here there are some indices values. Generally when you do clustering, you need to evaluate the cluster, right? So the cluster indices, you see here unique index and done index. Done index value is higher and there is unique index value 0.3 something, right? So that means once you get these two clusters, you need to evaluate how best these clusters are. How do you evaluate? There are several, many number of cluster indices. These are the concepts you need to learn. Okay? There are many cluster indices. You can find out Google, you will get it, and apply it to that particular cluster output and get the results like this. And these are the curves, right? Say for example, you take 10 in the output layer nodes 10, sorry not 10, iterations. You need to iterate the model 10, 20, 30, 40, like that, increasing the number of values of iterations. And you will get a curves like this. Okay? And among all these curves, which one is the smallest one? What is the value which you and whereas done index. So which is the highest value, right? So look at here at 30 iterations, highest value 0.9, and at the same iteration 30. 0.2 lowest value. Lowest value of DB and highest value of done index indicate that the cluster is better. So these are the simple two indices I mentioned here. So you need to understand what is index, first index. Okay? So if you plot these values with different other models like our proposed GSO and SOM and many models, these are the clustering models, right? You just type Google, all these models available, and you will get results. And we apply that different cluster index data done, DB and FRE, whatever. There are plenty of indices that according to the data you need to select. You need to identify which cluster index is better for your model. Okay? This is the project. Both here you need to do such type of evaluation and compare it and give a report. So for example, you take this one, data value is higher than the other models, that you can keep. And similarly, there are different indices and get those values, and according to the index, the model gets low value comparing with other models.
What should be the sample size?
Depends on any size, any in the data.
38, so is it sufficient for
No, here,
self-organization?
no. This is an example I am showing here, self-organizing map, I use 10 iterations. Samples are unique. So here I use number of samples. This data has almost 50 samples, two classes, 25 and 25.
Like any real model, will it require more number of samples?
Depending on the data. For example, you take some Irish data, as I explained previously, there are three classes,
Yes.
50, 50, 50.
Yes.
If you take satellite image data, you want to cluster that samples. So there may be one region has 100 samples, another region has 30, another region 40. The fixed values. That we need to speak it right. Partition in the image.
What are the applications of self-organizing map?
There are many, like this is one microarray data. Okay? So you take real life data, you take satellite image data, you take some image spectral image data. These are the applications, health informatics. There are many applications. So already you can do projects, do 4th-year projects. And finally, what you do, just evaluate those results, clustering results into some indices. These are the indices, right? You select some indices. There are many indices. I select only 4 here, and out of 4, 1 is main one, and 3 others. Okay. So like this, you need to do some sort of evaluation. Okay. Whenever people come and do some sort of, say for example, data you may get, right? So do clustering and select only 2 clusters and ignore the remaining clusters like that. So what I discussed in this presentation, some concepts of fuzzy set, right? Some concepts of fuzzy upset. How do we design some fuzzy similarity, relational matrix and granular self-organizing network. And I show one application of granular self-organizing network. Other application, microarray cluster. And results, we evaluate the clustering results using different indices. I have shown some plots. Okay. And how do we evaluate that? By clustering the patterns from the class 1 again as it is in the class 1. So like that we need to do clustering. So that's why uncertainty handling. And we have shown different comparisons, one model with other models, and identify which one is the best and compare with other models. Okay. So why I am saying these are the things you need to do in the project. About this concept, but the things you need to do is to take a model and apply data and use some indices, find out which model is best, right? And index is stored to the cluster. These are the problems you need to do in the project. So, and thank you. Any doubts? Yes. Okay, I need to forget about this project. What exactly you want to do in the 4th year or 3rd year? You can ask me some questions, I can give you suggestions. Yes, I used to say. Okay. Yeah, since it is a machine learning and AI engineering department, so you can ask me what to do or what are the things in future we need to do. You can ask me. I can give you. So you have a project here or somewhere outside? Huh? Listen. So what is the objective of this machine learning conference, FDP? At least you want to get some knowledge from this conference and FDP and apply it in the projects. Right? You are into the projects, right? 6 months or 1 year. So when you are planning to do project, understand? Huh? If you go to America, there will be something different thing. Nothing, there is no use that one. If you go at least doing something, you all know what is MATLAB? So just what you discuss, no clustering project, no classification project. Anyhow, I don't want to suggest more, we are not asking anything, so I will do it now. So can we start now? Okay, thank you. So now, no question? No question? Yeah, tell me. Tell me. You asked something, since it is machine learning work, right? Or a machine learning specific domain. So, no doubts related to machine learning so not for the general instruction. General parts, if you general doubts, if you ask, I can solve. At least I can use it. Another thing, that's what I was saying, you don't need to come to me, or you don't need to come to University of Hyderabad. And if you want to do projects, you can invite me sometime, like this. I can send you which projects are going to do, if you are going to some common agencies. At least here, in the department, use MATLAB, that existing software, through you can use, and MATLAB, R software. Yeah, Python is a pro software. There are plenty of tools, machine learning models, feature selection, dimensional reduction. Deep neural networks, nowadays people are working deep neural networks, right? Data science. So data science projects also you can do. Use deep neural networks. There is only deep neural networks, CNN, right? CNN, so what is your combination neural network? Part of data and nodes. This is a simple project. So we are only going data. When we apply CNN, so we are only going data. So take it seriously. When you are doing a project, at least you take it seriously. When you go to industry, people ask mainly what type of projects you have done. So if you are relieved from this machine learning department, mainly people ask questions related to machine learning. We are into some basic concepts of C programming and data structures. So you are interested to go industry, right? Yeah. And mainly this department related to machine learning, definitely people ask questions on machine learning. Even if you go industry or whatever. People ask what type of techniques you learn from this department. So your degree is based on machine learning and artificial intelligence. It's not a computer science, specific domain. Of course, it is a part of computer science, but mainly it is a specific domain. Okay, just you try to understand what I have discussed. Okay, and you take my suggestions, what I just explained and what I told. You don't want to take my suggestion, it will be up to you. Anything else you want to ask me? Anything else? Huh? Yes?
Any other doubts?
Forget about this presentation. You can ask general topic related to machine learning. I try to do some answers. Anything else you want to be asked? In Flickr website, people are not doing engineering college level, and some sort of IITs people at IITs and research institute, they are using this concept. Okay? Since my basic background from nothing else, that's just I explained. I thought that people from different engineering colleges will participate here, that's why I prepared accordingly. But if students are here, then I simply speak some tools. What is MLP, right? And what is convolutional network, what is the different things I should speak. At least you should understand what is the network and what is the use of this multi-layer perceptron, classification usually we do. And what is self-organizing, what is the recurrent neural network. Anyhow, so this time you just learn this one. Okay, anything you want to ask, you can ask me. Otherwise, I stop now. Industry mainly rough subject to use for uncertainty handling, right? Recently, just now I explained one micro. So there you can use medical images. Industry, some people work on medical image data, and some people work on rail data. There are plenty of uncertainty in rail data, right? So there we apply this concept. Or you can, people cannot know what is this publisher and website. They use simple models, like they apply self-organization, they apply multilaters, they apply CNN. They are all predefined models, right? And freely available in Python. These are the advanced topics. Generally, they don't know what this concept. Some industry people are working, like Google, Microsoft, they are working. Some small industry, some industries are not working. Right, they are the regular ML models. Anything else? Okay, next time we study first. Thank you.
Sir is a very good researcher. I hope you can see his profile in University of Hyderabad. Sir is a student of Institute of Statistical Institute, ISI, Kolkata. So where these kind of research are going on. I think, sir, you might be doing laboratory. Yeah, he worked here for a very small duration. So now he has taken. So he also worked in this area. Okay, for you people, this topic is a very new topic, but for our domain, this is one of the specific topics. And people do not choose, like at the university level, do not choose this topic for research because this is very complex to understand. Like sir told that we normally go for simple ML or regular DL models only, deep learning models to do our projects. But this requires a lot of expertise to understand rough fuzzy set theory. Wherever uncertainty is there in the data, like in the prediction process, wherever uncertainty is there we have to use these kind of techniques. Okay? So sir has worked on the self-organizing maps and he has developed his own model. So he was explaining about his own research work where he developed a new model. And he is a contributor to IEEE also, which is a very great thing. Normally, we like researchers cannot contribute to IEEE. Am I right, sir? So it's a dream for a researcher to publish a paper in IEEE also. Sir has written a book also on rough fuzzy set theory. So now at this moment, it may not be useful for you, but when you grow up and you work in industry, obviously these things will help you a lot. I hope it is understood. So afternoon session will be taken by Dr. Madhu sir from VNR VJIT. He is a very good professor and he will be teaching about from the basics, from the scratch, the neural network concept and the CNN model. And I have told sir to teach the students at the student level. So I hope you will utilize the session and it will be up to 4 o'clock. Okay? So thank you so much. Thank you so much, sir.
Now I request Dr. Nagaraju sir to facilitate our
Thank you.